Hi guys, I'll be discussing a little bit about your theory as well as practical exam on what to expect and what needs to be done. Okay, practicals I'll discuss in detail. In terms of theory, you need to stick to the question bank. The question bank itself is very vast. Okay, so if you want to do extra, I wouldn't stop you, but my advice would be to stick to the question bank and also from my observation, see, among the 40 questions in all the four papers, there will be hardly some three or four bouncers. Rest of them will be from the past 10 years. So there is no point in aiming for those, three to four questions, which obviously you will write somehow. You will remember something from somewhere and you will be able to write something. Right. So try to do the past 10 years properly. That time, the other questions you will be able to write really well. Okay. And the next tip is to not write too much. Okay. Write only the key points, and they're not going to give anywhere more than 6 to 7 for each question. So don't waste your time on one question unnecessarily. Stick to a time limit. Okay, ideally I'd say you better stick to 12 to 15 minutes. Or there was this other thing that I was doing for my third and fourth paper, that is I kept a goal of 5 questions in the first hour. So if I'm not able to do that, then my second hour needs to be really fast, so that the third hour is for those questions that probably I don't know that well, or the questions that I need to organize my thoughts about. So the first 1 hour you're only going to write the questions that you know properly and you have a good flow about and you have a structured answer already. Okay, everything else you're going to come back and do it. And in 3 out of my 4 papers I didn't write the first question. I ended up writing it at the end because I felt it was like they were pretty lengthy and I had to think and write it in a certain way, and that was going to take me time, not something that I could finish in probably 12 minutes. So yeah. And whenever you're writing something like a key point or an important rare finding, try to underline it. You can put inverted commas, something like that. Just highlight it, okay? And write under headings. That is extremely important, because if it's in an organized way, then the examiner also feels like, yeah, this is, very much structured, and the examiner is going to be impressed because they're also going to have only 5 to 10 minutes to correct a 50-page answer booklet. So they are not going to spend a lot of time on each page reading each and every line. So highlighting and headings are very important. Okay, now coming to practical exam. So most of us we don't know what to expect in a practical exam, and that actually becomes a kind of a hurdle in preparation because you don't know what you're preparing for. So that is why we are having this session. Okay, so basically you will have one long case, two short cases, two fundus cases, and two refraction cases. Okay, and we'll see what each of these are. Coming to long case is the most expensive fruit in the basket. Basically you need to write a detailed history. You need to write okay, it will start with patient details, chief complaint, history of presenting illness, then detailed explanation of the presenting illness, followed by negative histories, then a detailed examination which will include general physical examination, vitals, review of systems, briefly, not too much in depth, then ocular examination with the detailed vision and anterior to posterior up to fundus detailed examination, and if there is anything else, that extra examination, followed by a provisional diagnosis. So that is the end point of a long case. So long case is something that you need to master. The reason being that will be the first session for the most of us, and you make an impression with this, right? So if you make a good impression, the rest of it, the examiner is going to be a little kinder to you. So this one you need to really do well. Okay. So it's going to be usually it's a glaucoma case, rarely a nerve palsy or a proptosis or something, and most of the time it's a primary open angle glaucoma, angle closure glaucoma, or neovascular glaucoma, one of these things. So I would suggest you guys go through Namrata Sharma, that ophthalmology clinics book, which has everything in detail, like and Kansky. These two things, if you do for glaucoma long case, it provides 100% of the information, so you'll be fully prepped. Okay. Yeah, vision. Okay, coming to vision, this is one important thing that I want to tell you guys. So actually you will also be scored for the way you are presenting, so it does matter. Okay, so you need to present in a sophisticated manner. Now when you start the history, you'll be like, I'm presenting a case of a 50-year-old male who's blah blah blah, who presented with complaints of so and so in chronological order, and description which was insidious in onset, gradually progressive. So these are basic things which we've been doing from UG, so we will not have any issue with it. And when they ask you to summarize the entire case, you are supposed to tell only the positive findings, okay, no negative history. But when it comes to presenting vision, a lot of people will be like, distant vision, 6/6, whatever. No, that is not the way to present vision. Vision needs to be presented this way. The uncorrected visual acuity for distance as checked by Snellen's chart was 6/9. Oh yeah, I'm sorry, I made a mistake here. The thing is, the uncorrected visual acuity of the right eye as checked by Snellen's chart was 6/9, which improved to 6/6 on pinhole, with an acceptance of so many diopters of sphere cylinder at this one, indicating a compound myopic astigmatism, whatever, with the rule against the rule. So this is describing everything. Okay, then you'll go to the left eye and do the same thing. For a long case, you need to say this very long sentence, whereas in case of a short case, sometimes only only 6/6 or something like that will be given. Like there won't be any kind of excessive. They will give you the BCVA basically, right? So in such a case, you need to say just one sentence. The best corrected line visual acuity as checked by Snellen's chart for this patient is 6/6. End of story. Okay. Yeah. That is about vision. See, when you present vision in a nice systematic manner, you make a good impression. Okay, then the examiner is going to be kinder to you in terms of his questions later on. Yeah. So you're going to have two short cases. Short cases, basically you'll have a brief history, very brief, not excessive, and then focused examination. The examination that will help you to arrive at the diagnosis. So you just have to do ptosis evaluation or a squint evaluation, something like that. Okay, and you'll arrive at a provisional diagnosis, and you'll have a few DDs, if any, and plan of management. That's it. Okay, now we move on to fundus charting. The name of the fundus chart is also important because some examiners can ask you that. It's Amsler-Dubov. Okay, the spelling is a little different and that's why I have written it. Now, I'm just going to give you a few tips on drawing a neat fundus diagram. And that is to carry a compass. Don't expect yourself to, draw these circles just by hand, and that is going to be very, very difficult because you need to draw. You'll have two fundus cases, and each of these fundus cases are going to have a right eye and a left eye. So totally you are drawing 4 fundus. Then you will have a fundus in the long case, 6. So 6 of these 3 circles you're going to draw. If you are going to get a compass to the exam, you're going to save yourself a lot of time and it's going to look very neat. Okay, So first thing first, you'll draw 3 concentric circles and mark all these clock hours. Just a second. Okay, you're gonna mark all these clock hours, these. Okay. Then this let's assume this is the presumed center of the chart, so that is approximately the fovea. Then 2 disc diameters away from it, I've drawn the disc. Okay, and that is supposed to be small. Don't draw it too large, okay, because we are drawing the entire fundus. When comparing to the entire fundus, the disc is very small. Then and it has to be approximately 2 disc diameters away from the fovea. Then we'll draw the vascular arcades. We draw the veins, not the arteries. This is very important. Okay. Now, when we are drawing this, the third branching is supposed to be at the equator. Okay. Draw it in such a way that the first dichotomous branching is somewhere in between, whereas the third branching of all of the vascular arcades is at the equator. Okay, the inner circle is the equator, then the middle one is the ora, and the last one is the junction of pars plana and plicata. Okay, and alongside all of this, you need to draw the ora. And if you observe, the oral base and the dentate serrations of the ora are more crowded on the nasal side compared to the temporal side. Okay, so these are little details. If you concentrate on that, you will have a very neat diagram. And in terms of marking the horseshoe tears, lattice, all of that, there is a diagram in Namrata Sharma. That one page will give you all the color codings. If not, I'll share my color coding chart. Basically, I've copied from Namrata Sharma, so there is no point in me sharing it. It's the same thing basically. Okay, yeah. So you would have drawn the fundus chart. Now coming to the presentation, because there is an order for presenting a fundus case, and when you follow that order, it is systematic, and that is what is expected in a fundus case, for you to present it in that way. The order is simply this. Just a second. Okay. So it will be first media, then disc, then vessels, then posterior pole, background retina. Okay. Now, let's say I'm presenting a case of a 53-year-old male who presented with so-and-so complaints, and on fundus examination, the media appeared to be clear and the disc was normal in size, shape, whatever. If there's bayoneting, all those details you will describe. Then vessels. Okay. Oh yeah, there is an important point here. Okay, I'll explain later. Okay, then you will describe the posterior pole. Okay, if there are hemorrhages, exudates, if there is retinal thickening within 500 microns of the center of the macula, then there is clinically significant macular edema, suggestive. Oh yeah, one more thing, just don't directly say that there is this. Okay, so you can describe it in a way that is retinal thickening within 500 microns of the center of the macula, suggestive of clinically significant macular edema. Okay. Also for hemorrhages, also for RD, so undulating, convex, blah. Okay, all of that suggestive of a retinal detachment. So don't directly say there is a retinal detachment, and when you're describing a retinal detachment, you need to explain the extent. That is, it is extending from these many clock hours to that many clock hours, and you need to mark that detachment. And most of us forget to shade the red for the background attached retina. which is important in all cases. So you need to do that even when there is no RD. So you need to remember the shading part. Yeah, so media, if it's clear or not, disc, vessels, posterior pole, and then just general comment on background retina. After that, you will comment on, after that, you will provide your provisional diagnosis and plan of management for the same. Now, one thing I wanted to discuss about vessels was the arteriovenous ratio. Now, here, as I've marked, AV ratio 2:3 is normal, right? When there is arteriolar attenuation, we write it as 1:3. Now, what is this 2:4? Is this equal to 1:2? No, it is not. Okay, this means that the venous caliber is increased, that is, there is venular dilatation in the presence of a normal arteriolar caliber. The arteriolar caliber is normal, yet the veins are dilated. Okay, so you need to know that these are the combinations that are available. So don't try to write anything other than these. Okay, so that's about fundus. So fundus is all about how well you draw, how neatly you've drawn, and how well you have labeled, and how uh, and how you've presented it in a structured manner. That is media, disc, vessels, posterior pole, and background retina. And from all these findings, whatever provisional diagnosis you arrive at and plan of management. Simple. You'll get 2 of these cases and they are very easy to score, and you should score well in these. Now let's move to the next one. Refraction. Now refraction is the most scoring of all, okay? Because this is something that is going to have not too much of a marks at stake, but you can earn almost all of it, okay? Because the viva for refraction is very short, because they hardly ask 1 or 2 things, because most of the marks is for the refraction itself. Okay, so I thought I'll explain the refraction thing in detail, because a lot of people have a bit of doubt and confusion regarding refraction case, which is basically very simple. There's hardly anything, but then I'll just give you a structured way of coming to the final diagnosis so that it's easier. Okay, and the others who already know how to handle a refraction case can actually stop watching this at this point. You need not waste your time any further, because after this the discussion is only about refraction case and nothing else. Okay, so the question is this cross, and it's a wet refraction. Basically, there is a cycloplegic that was used, that is cyclopentalate at 2/3 meter. Oh yeah, one advice I would want to give you: if you have a patient in it's unlikely these days to have patients during examination, but say they give you a live patient, then don't waste your time too much in getting the glow. So once you get the glow and you are pretty sure it's the glow, just write down whatever you get. Okay, if you are too confused, just take the point end point as the point of reversal of moment. Okay, and if the examiner asks you what is the source, you can tell that it's Elkington, because it is written in Elkington that you can either take glow or end point as the point of reversal of moment. Okay. Yeah, let's solve this. Okay, so the first step would be to directly convert this to a prescription before correcting for cycloplegia and the distance. Okay, so let's do it. Now, since both are of the same power, I'll take the smaller one. Okay, so I'll take 2.5D sphere. Okay, so once I've written here, I have removed plus 2.5 from all the meridia. So, okay, It is basically minus of plus 2.5D. So this becomes 0. Okay. Now when I remove 2.5D from here, only plus 1D remains. Right. Okay. So plus 1 diopter cylinder at, if it is acting in this meridian, the axis of the cylinder is perpendicular to it. Okay, so this is 180. Then I'll write 90 here. Done. Shall we do the same thing for the left eye? Plus 3 diopter sphere with, okay, I'm gonna write here, plus 1 diopter cylinder at 90 degree. Simple. Now, the next step would be correction for cycloplegia. Okay, I'm going to write cyclopentolate itself. And distance. Okay. For cyclopent, it is 0.75 diopters. For hometropin, it's 0.5. For atropine, it is 1. Okay. Yeah, for distance of 2/3 meters, basically you need to take the reciprocal. So reciprocal of 2/3 is 3/2, which is basically 1.5 diopters. So total deduction oh dear Lord, there is no space. Okay, total deduction from sphere. Okay, you are not deducting anything from cylinder, from sphere only. It's 2.25. Okay, so now let's apply this to the sphere there, so we have the final answer. Okay, it's going to be 0.25 plus, yeah, please don't forget the signs. Okay, they're very important. The cylinder is going to remain the same. Okay, it's not going to change at all. You're going to write the same thing. This is right eye. OD. OD is oculus dexter. OS is oculus sinister. Okay. Yeah, 2.25 needs to be removed. So that will be 0.75 D plus 1 and 90 degree. Okay, so as you observe, the deduction is only from the sphere. That is why don't try to deduct all this from the cross cylinder. Sorry, from the refraction cross. If you try to deduct all of that from the refraction cross, you're going to create a lot of confusion. So that is why convert the cross to a prescription. Then do the correction for distance and cycloplegia. Okay. And then the correction is always only from the sphere. That is super important to remember. Don't deduct it from everywhere. It's only from the sphere. Okay. So now, this is not the end of it. The end of a refraction case is the diagnosis. Right. Now, how will you write the diagnosis? So basically, this is a compound hypermetropic astigmatism with the rule. Okay, it's a pretty simple example, but this is something a lot of people get confused with. So we'll have a discussion after this one. Here with examples, I'll teach you a little bit more about how to, how to make this diagnostic sentence of simple or compound hyperopic myopic astigmatism with or against the rule. It is very, very simple. There's hardly anything in it. But yet I'll just, anyway, I've explained so much, so I thought I'll finish the whole thing. Okay. The next important thing is spherical equivalent. This is something a few examiners like to ask. That is, see, the concept is only this much. That is, the sphere is acting in all meridia. The sphere is acting in all meridia, whereas the cylinder is acting only in one. Basically, the perpendicular one, perpendicular to its axis. So, the sphere's power is full, whereas the cylinder's power is half. So the spherical equivalent is full spherical power plus half cylinder. So in this case, the spherical equivalent for the right eye will be 0.25 D plus half of 1 diopter of the cylinder. Okay, actually the plus is here. Now it's right. Okay, so that is going to give you a plus 0.25 D plus 0.5 D. The spherical equivalent of this prescription is 0.75 D. That's it. Full sphere, half cylinder. The reason why I am keeping the signs is because when there is a minus sign, then the addition will result in minus. So let's okay, I better give an example rather than making correction here. It will simply create a lot of confusion or else. So basically the concept is full power of the sphere plus half of cylinder. Okay, that's it. Transposition is very, very easy. There is a section in Elkington that can make you understand that in like probably 5 minutes. It's very, very simple. There's hardly anything. Sum, sine, axis. Okay. Okay, I'll use the same example. Let me just write the same thing down here. 0.25 D plus 1 DC at 90 degree. So you get the sphere by the sum. That is, you will add these two. So it becomes 1.25 D. Okay. Done. We got the sphere. For the cylinder, you're just going to change the sign. So plus, I'll make it minus 1.00 DC. Axis, make it perpendicular at 180 degree. That's it. Take the sum of both to get the sphere. Change the sign for the cylinder. Perpendicular axis. That's it. That is transposition. Okay. This is transposition of a cylindrical lens. A cylindrical lens is different from a toric surface. Okay. Because a toric surface at the end of the day is a cylinder that has been bent along its axis. Okay, it's a little complicated thing. Let's leave that. Now, as I said earlier, I'll explain on how to arrive at this provisional diagnosis. I told you guys that this is a compound hyperopic astigmatism which is with the rule. It's very simple. We'll do it with examples and you guys will understand in no time. Okay. Before that, I think let's do a bit of a conceptual thing. Yeah. See, in the figure A, parallel rays of light are coming to a focus on the retina with accommodation at rest. So that is the state of emetropia. If they're coming to a focus in front of the retina, then it becomes simple myopia. If behind the retina, then simple hyperopia. This is conceptually easy, nothing much. Now, when the two principal meridia are focusing them in two different planes, and one is at the retina and another in front of the retina, then it becomes simple myopic astigmatism. When one is behind the retina and another on the retina, it becomes simple hyperopic astigmatism. Okay, even this is somewhat simple, right? Conceptually to understand, nothing much. Now, when both the principal meridia are focused in front of the retina but at two different planes, then it is compound myopic astigmatism. Same goes with compound hyperopic astigmatism. That is, they're focused behind the retina but two different planes. Okay. If one is in front of the retina and another behind, then it is mixed astigmatism. That's it. Let's now try with examples, because you're going to get a prescription and you need to, correlate that and do this. But that correlation takes a long time to, do and, arrive at. So there is actually a simple trick to follow. Now, if there is no cylinder in the prescription, only sphere, then there is no astigmatism. Look at the sign of the sphere. If it is minus, then it is just simple myopia. If it is plus, then it is just simple hyperopia. Okay. If there is cylinder, only then astigmatism is coming into play. Okay. Now, I have only described astigmatism because that simple spherical thing is obviously very basic and I'm sure all of you guys know. So, yeah, let's go to the first example, this one. Here, there is no sphere. This sign indicates the spherical power is 0. Okay, and there is a cylinder of minus 2. Okay, at 180 degree. When the sphere is 0, only the cylinder is acting. That too in one meridia. The other meridia, it is focusing on the retina. That's what it means. So, when the sphere is 0, it is simple. Look at the sign of the cylinder. It is minus. Myopic. Astigmatism. Easy, right? Okay, let's move on to the next one. Second one. No sphere. Only cylinder. Simple. Plus sign. Hyperopic or hypermetropic. Same thing. Astigmatism. Okay. Then comes third and fourth. Now third and fourth are different from 1 and 2. Why? There is a sphere. Okay. Once there is a power in both sphere and cylindrical column, you will look at the sign. They are of the same sign. Right? Okay. So, it is compound. Okay, before this I need to tell you guys a little bit something else. That is, see, when they are having the same sign, that means the refractive error is in such a way that both are either in front or behind. In case of this plus thing, both are behind the retina. In case of this minus thing, both are in front of the retina. The only confusion comes when the sphere and the cylinder are having different signs. Can you see here? Yeah. So when this happens, you need to look at which is bigger. Okay, because this can either be simple or compound astigmatism, astigmatism or a mixed astigmatism also. Okay, so this one will require a bit of intensive thinking. before that, let's do the easy ones. Okay, so as I said, both meridia are in the same direction, but nothing is on the retina. So this is compound plus hyperopic astigmatism. Again, there is a sphere as well as a cylinder, and they're of the same sign. So this is compound myopic astigmatism. Okay, let's move on to the end of the discussion and the only complicated thing. Okay, so here, as I said, there is both sphere and cylinder, but they are not of the same sign. So when they are not of the same sign, you need to actually see the value. Okay, you'll have to see the value of the sphere and the value of the cylinder. It is the same value. Here, sphere is bigger, cylinder is smaller. Here, the sphere is smaller, the cylinder is bigger. Each of these are going to have different results. Okay. When the sphere is equal to the cylinder, that is same, means simple. So simple. Now myopic or hyperopic, always look at the sphere. When the signs are different, you look at the sphere. You see if the sphere is same as the cylinder. You see if, what is the sign of the sphere. It is plus. So this is actually a hyperopic astigmatism. This seems a little confusing, right? But the thing is, +2 is acting in all meridia, whereas -2 is neutralizing it in one meridia. So it becomes 0 in that meridia. So there will be only +2D remaining in one of the meridia. That is basically the one that is perpendicular to -2. I'll explain that again. See, when you give a sphere of +2D, +2 is acting in all the meridia. Now, -2 diopters at 90 degree, that will act in the 180 degree. So it's going to remove that +2 and it will become 0 in this meridian, whereas only +2 will remain in this meridian. And that is why it is actually a simple hyperopic astigmatism. So you don't have to use your brain so much during exam. See if there is a sphere and a cylinder. See if they are having the same sign. If they're having the same sign, it's easy. It's a compound myopic or hyperopic astigmatism. If they are not of the same sign, see the value of the sphere. Compare it with the cylinder. If it is same, then simple hyperopic astigmatism. Hyperopia or myopia, you will check with the symbol or the sign of the sphere. Okay. Now, the next example is showing us a higher sphere. Okay, so there is a trick to remember this. Here, the sphere is the chief or the commander because it is of larger value. It's larger, so it is chief or it is a commander, whatever helps you remember. So you will write compound. Now, you will look at the sign of the sphere. So again, this is hyperopic astigmatism. Okay. Now, this is the last example is the trickiest of them all. Here the sphere is smaller than the cylinder. When the sphere is smaller than the cylinder, that means one meridia is plus, the other one is negative. So this is actually mixed astigmatism. Okay. Same thing, you'll see if there's a sphere and a cylinder both given, same sign? No, not a same sign. It is plus and here it is minus. And so you will look at the value of the sphere. It is lesser. Once it is lesser, it is mixed. Okay, we have actually solved all types of problems. Now the only thing that you guys need to learn is to differentiate with the rule from against the rule astigmatism. This is very easy. A plus cylinder at 90 degree and a minus cylinder at 180 degree is considered to be with the rule. Okay, so plus 90 minus 180 is with the rule. Anything other than this combination is against the rule. That's it. There is also another way to remember it. Okay, a plus is like a perpendicular, or you can actually take a plus as a vertical line. Okay, and 90 degrees is again vertical, right? So both the lines are in the same direction, so it is with the rule. Minus is a horizontal line. 180 degree again is a horizontal angle, as you can see here I've drawn. Okay, so again the lines are in the same direction with the rule. In against the rule, see, minus, but 90 degree is a vertical line. They're not in the same direction against the rule. Plus, but plus, okay, plus is taken as a vertical line and 180 as a horizontal line. They're not in the same direction and therefore against the rule. Okay, we are done with everything. So the provisional diagnosis you will write as simple hypermetropic astigmatism with the rule or whatever. This is the complete diagnosis for a refraction case, and you know how to get the spherical equivalent as I explained. And transposition again is very easy. Sum, sine, axis. That's it. And I've explained this already. Yes, that's it. Thank you guys.